IPv6 is a relatively new IP protocol developed to fix the shortcomings of the current IP version 4 implementations. When IP version 4 was standardized, the current challenges were not anticipated. The challenges include exponential growth of internet usage, scalability of large protein tables on the internet backbone router, supportability of real-time data delivery. IP version 6 not only fixes these problems but also provides improvements to IP version 4 in areas such as IP security and network auto-configuration. With the increased use of IP-enabled wireless phones and PDAs, the IP version 4 address space is running out. Also, network techniques such as network address translation (NAT) and short-term DHCP lease have helped to conserve these addresses. More and more home users are demanding always-on internet connections. IP version 6 header. IP version 6 specifications describe an IP version 6 header as shown in figure. In the case of IP version 4, an IP addresses is represented in 4 octets, separated by dots. To accommodate a 128-bit IP version 6 address, the address is divided into 8 blocks of 60 bits each, separated by clones. Consequently, this representation is referred to as clone hexadecimal notation. Version: a 4-bit Internet Protocol version number 6. Traffic class: an 8-bit field that enables the source to specify a desired delivery priority of its packets relative to other packets. Flow label: 20-bit field that may be set to request special handling of the packets by the IP version 6 based router. Payload length: the 16-bit integer that specifies the length of the data payload. Next header: an 8-bit field that identifies the type of header following the IP version 6 header. Hop limit: an 8-bit integer that is incremented by 1 whenever the packet passes through a network node. Source address: a 128-bit address to identify the packet's source. Destination address: a 128-bit address to identify the packet's destination. The following are a few examples of IP version 6 addresses. Configuration IP version 6. The security appliance supports a number of IP version 6 features which include IP address assignment, packet filtering, base routing using static routes, neighbor discovery, limited remote access VPNs, and IP version 6 supported application inspections such as FTP, HTTP, and SMTP. The security appliance supports 4 types of interface address assignment: global unicast address, site local address, link local address, and auto configuration address. Global unicast address: a global unicast IP version 6 address similar to an IP version 4 public routable address is used for internet connectivity. It uses a prefix of 200 /3 and requires a 64-bit interface identifier in the Extended Universal Identifier 64 EUI64 format. Each physical interface has an embedded 48-bit MAC address that specifies a unique link layer address. You can derive the EUI64 format interface ID from the interface MAC address by using the following rules. Insert FFFE between the up and lower 24 bits. For example, if the interface's MAC address is 000f.f775.4b57, the modified address will be 00f.f7ff.fe75.4b57. Change the 7th bit in the leftmost byte to 1. For example, if the 64-bit address is 00f.f7ff.fe75.4b57 derived in the previous step, after the 7th bit is changed, the new addresses becomes 020f.f7ff.fe75.4b57 192.168.1.57. This new address is in the EUI64 format. Site local address. A site local IP version 6 address similar to an IP version 4 private address is used for the host on the trusted networks that do not require internet connectivity. It uses a prefix range of FEC0 ::/10 and they use the EUI64 format interface ID for a complete IP version 6 address. Link local address. A link local IP version 6 address allows IP version 6 enabled hosts to communicate each other by using the neighbor discovery protocol without needing to configure a global or site local address. The neighbor discovery protocol provides a messaging channel on which the neighbor IP version 6 devices can interact. It uses a prefix of FE80::/10 and the EUI64 format interface ID as the complete address. The link local address is auto-assigned to an interface when IP version 6 is enabled. Example shows complete IP version 6 interface configuration on the outside interface. Neighbor solicitation message. These messages are sent to perform duplicate address detection. By default, the security appliance sends one duplicate address detection message on an IP version 6 enabled interface. The security appliance sends neighbor solicitation messages only when it needs to do neighbor discovery. You can change this behavior by specifying a new value under the that attempts option. If you specify value of 0, the security appliance disables duplicate address detection on the interface. If you configure an interface to send out more than one duplicate address detection message, you can also specify the interval at which the neighbor solicitation messages are sent out. The security appliance sends out one message every second. You can change this behavior by specifying a new value under the NS interval option. Neighbor reachable time. The neighbor reachable time is the amount of time in milliseconds that a remote IP version 6 node is considered reachable. The security appliance can detect the unavailable neighbors in an IP version 6 network by using the neighbor reachable time. If you define short reachable time, the security appliance can quickly detect unavailable neighbors. However, it adds bandwidth and processing overhead on the IP version 6 enabled device, and thus configuration short reachable time is not recommended in a typical IP version 6 network. You can change this behavior by specifying a new value under the reachable time option. The default value of 0 indicates that the reachable time is sent as underdetermined. It is up to the receiving devices to set and track the reachable time value. Router advertisement transmission interval. A security appliance can send router advertisement to an all nodes multicast address so that neighboring device can dynamically learn a default router address. The security appliance includes the router lifetime value to indicate its usefulness as the default router on the network. You can change the router lifetime from its default interval time of 1800 seconds by specifying a new value under the RI lifetime box. Router advertisement messages use ICMP version 6 type 134 and are periodically sent out to all the IP version 6 enabled interfaces. If you would rather change the router advertisement interval from its default value of 200 seconds to something different, specify a new value in the RI interval box. The transmission interval must be less than or equal to the IP version 6 router advertisement lifetime. Example shows the gigabit Ethernet 0/0 is set up or a neighbor solicitation message interval of 2000 milliseconds, a neighbor reachable time of 10 milliseconds, and a router lifetime value of 10,000 milliseconds. The security appliance is also set up to express router advertisement messages on the interface.